Good morning to one and all. In the last class, we have discussed about collision theory, Arrhenius equation, that is temperature dependent rate equation, and about reaction mechanism. Today, we shall discuss factors which affect rate of a chemical reaction. These factors are number 1 temperature, 2 concentration, 3 pressure, 4 surface area, and 5th presence of a catalyst. Now come in the next slide. How does this temperature affect rate of reaction? What happens when we increase the temperature? It will increase its kinetic energy. Obviously, with the increase in kinetic energy, collisions will be increased, as a result of which number of particles which will be increased through collisions, it will create amount of activation energy, and as the activation energy will come into play, definitely it will increase more particle reaction, and therefore rate of reaction will be increased. Is it clear? Now come in the next slide. It can be very clear through an example. Just to think, why do we keep a food in freezer? When we keep a food in freezer, what happens? It does not turn stale. It does not turn bad, in bad condition. Why? Because rate of reaction decreases. Its answer is actually in the next slide, which is the same answer is written here also. Due to low temperature, what happens? Chemical reaction will be lowered, and therefore food will not turn bad. So spoilage of the food will be stopped. Okay, now come in the next slide. Now the second factor is concentration or pressure. Concentration of what? Concentration. When the concentration of reactant is increased, means high concentration is being taken, definitely in a certain volume, number of particles will be increased. As a result, again come to collision theory, it will increase the frequency of collision, which will enhance or improve the rate of reaction. So in brief, we may say high concentration will increase rate of reaction. Okay, now come in the next slide. Surface area. Third factor is surface area. Surface area, greater is the surface area, it will affect the more exposure of the reactant. Definitely, probability of collision will increase, and that will increase the rate of reaction. Now, the fourth factor is presence of catalyst. Presence of catalyst will affect in what way? Actually, what happens, as you have studied, you have read in collision theory, there is an energy barrier in between reactant side and product side. It requires certain amount of energy to cross that barrier. And when we use a catalyst, it will down that energy barrier, and therefore comparatively in a easier way, reactant molecule will cross that barrier and come into which side? Product side. That means product is being formed. So this way it is speed up. what? Presence of catalyst also speeds up rate of reaction. So this is clear. Now come at last, these are total factors which we have discussed. How do they affect this rate of reaction? And you must note down all these things in your classwork copy, and wherever you feel problem, you will discuss with me. But once again, I would like to brief all those things which we have covered in this chapter. So as this is very clear, this chapter was what? Chemical kinetics. Yes, let me come at the start, that is chemical kinetics. This we have discussed. What is chemical kinetics and why do we need to study it? This we have discussed. Moreover, reaction rates. What are rates of reaction? In what way it can be represented? What is chemical kinetics? What will be the formula to show that rate of reaction? All these are clear in this slide. And this rate of reaction, which when we plot a graph, how it will be reflected, this is in this slide. And the rate of expression, which we have discussed in the chapter, rate of expression, all these slides are covering the same thing. And when we come to rate law, a constant is being used, that is K, which we know as rate constant. This we have discussed. Then we discussed order of a reaction. This order of reaction and the rate of expression, which is indicating somehow towards rate of reaction, rate law. And that rate law contains certain power of concentration of reactant site. Here in this slide, that is indicated as M and N. That is indicating towards what? Order of reaction. So rate of reaction also indicates towards order of reaction, which we have discussed. Now, thereafter we have discussed about first order reaction and second order reaction. What are the different format of representing them? All these are clear in these slides. Sometimes we represent it in form of formula, sometimes graphically we represent it. Likewise, zero order reaction we have discussed, units of K we have discussed, moreover temperature and rate constant we have discussed. And this way, temperature dependence of the rate equation, that is also known as Arrhenius equation, we have discussed. Integrated rate equation we have discussed. Collision theory, activation energy, and exothermic endothermic reactions and reaction mechanism, all these things we have discussed. And at last, now just today we discussed factors affecting rate of chemical reaction. So I think no need to discuss it once again. This way, this chapter is now over, and I think now wherever you feel problem, you will discuss with me. It's okay. Have a nice day. Thank you.